Hello and welcome to our next topic, which is circle properties. So a little bit different than vectors, a bit of a change of pace. So what's the learning goal? I want you to be able to determine the angle between two chords, the measure of the arc subtended by two chords, and whether two lines are tangent, and determine the perimeter of a polygon, which has a circle inscribed inside it. So, wow, lots of stuff there. A lot of it's simple little concepts, just need to see them. And you'll have your cheat sheet to work your way through. But once you see them, pretty simple to keep straightforward here, keep track of. So first thing I want to do is talk about definitions. So a couple of new definitions here. Some people might remember these already. So I got two circles drawn for us, so that we have a little bit more room to write. So anything that touches the circle in one particular location is what we call a tangent. If it goes from the center of the circle to the edge, we call that the radius. So we have radius in that same circle. If it goes through the middle from side to side, we call that our diameter. Diameter. And that's getting crowded enough. So moving to the other circle here, just to add a couple more in. If we have a line not go through the middle, but go from end to end, we call this a chord. And we call the piece that it cuts off, so this blue region here, that is called a segment. All right. And if we draw in two radiuses, it gives us a whole bunch of definitions here. So I'll do one at a time. So this angle right here is our subtended angle, I guess I'll use that word. So that's a subtended angle. Use a different color. My colored in blue region, that's our sector. And finally, the outer edge of the circle that extends from here to here is what we call our arc length. All right, so those are some of the definitions that you're going to come across in the next 3 or 4 lessons here. So I just want you to be made aware of the terminology. So let's talk about some of the properties. I'm just going to run through. So we have what we call the inscribed angle theorem. So this is some triangles that have been placed inside a circle. The first one's the right triangle, and it simply says, if we use the diameter to build a triangle, then the angle that touches the edge of the circle will always be perpendicular. All right, so a couple properties here. Diameter is base of triangle. Now, if that's true, then part 2, we'll call it angle A. Angle A is always 90 degrees. Okay, so anytime you have a triangle where the base is the diameter, any triangle you draw will be perpendicular, will be a right angle. And you probably found that from the investigation if you've started with that. Next, I call it the bow tie. So basically, we take two chords, doesn't matter what the chords, the orientation, and then we connect the chords to the diagonal, and we get what we call the bow tie. So I call that the bow tie. What the bow tie tells you is that corresponding angles are in fact equal. And that comes from similar triangles. All right, so corresponding angles are equal. All right, and I'm not going to go through the proof of it. Back in grade 9, you did all the geometry necessary, so you don't have to add this in. But if we look at the solid dots there, and that's a little aggressive in terms of color, but if we look at this part here, this is what we call opposite angle theorem, OAT. So when two lines cross, opposite angles are equal, so that's why the solid dots are like that. And then from there, what this does is it creates what we call similar triangles, and because they're similar triangles, the angles inside all correspond, are all equal. So there you go with the bow tie. Finally, I call this the Star Trek symbol. That's because I'm a bit of a geek and I like Star Trek, and that's the first thing I thought of when I saw this particular property given. So the Star Trek symbol basically has two radiuses, or radii, okay, from the center of the circle. And if you see an O, it means that those are coming from the center of the circle. So I should add that up top here. So O. Now, the bow tie does not go through the center of the circle. Please note that. This one does, though. And to finish off the Star Trek symbol, because I know everyone's eagerly wanting to see how much of a nerd I am. If you don't know this, pause the video and go Google Star Trek, and it's the little symbol that they have on their uniforms. Yeah, I know. I am ultra cool. That's what you're thinking right now, and that's awesome. So anyway, there's the Star Trek symbol. So what does the Star Trek symbol tell us? If we know this angle up top to be x, the angle at the center of the circle, or subtended, is twice as big. All right, and that's always true. So the angle at the center, at the center, losing control. All right, try that again. Cut, and cut. Angle at the center is always twice the angle at the outside. So there you go. So I got a couple of examples then in the next slide that we'll run through, and you'll see that once these are on your cheat sheet, they're not that difficult. So what's the question going to look like? There's the center of the circle. It's simply going to say, hey, what's this angle up here? So I'm just going to do this on a test, and this is what it'll look like on the test and on the exam. So what's x? Hey, G, the base of the triangle goes through the center of the circle. It's the diameter. So therefore, x is 90 degrees. And you can see I went ahead and I paused the video so I can put in some of the other information for you, save a bit of time. So the next one is our Star Trek symbol, and we know that the angle that's at the center here, the angle that's here, is always twice as big as the one at the edge. So therefore, x will be, and I'll do the extra step here for the note, it's going to be 1/2, so it's at 80 degrees. Number 3 is then the partner to that one, and it's the opposite direction. We know that the angle on the outside edge is actually half the middle one, so that means in this case, x will be twice 50, and that's how we get 100 degrees. And finally, the bow tie, one of the most difficult and challenging ones of all. As soon as you identify the bow tie, and again, the bow tie, if you don't know what a bow tie is, better Google that. All right? All the cool people wear bow ties. Once we know that, we just need to agree that these are corresponding angles, so therefore, x is 20 degrees. And that's it. Those are the types of questions you can expect. There's only so many variations on it. So like I said, it's not overly challenging once you have the 3 basic shapes drawn out. Moving along here, the next one is tangents and circles. So I want you to see 2 tangent theorems here. And basically they're broken apart because we can't put them all on the same page or on the same drawing. It gets too complicated. That's the only reason there's an A and a B. So the first one is, if I have a tangent to a circle, and again, a tangent means that it touches the circle only in one location, then if we draw the radius to the center of the circle, so I'm going to say that's the center, if I were to draw the radiuses from where there's contact, the tangents always make 90 degrees with the radius. Okay? Always. So the first one here, tangents are always perpendicular to the radius. All right. So there you go. The next one, tangent theorem B, if I take a location, and we're going to call it point A, so any point A, and I draw 2 tangents that pass through point A, So that means that this one right here that I'm waving around, after I have point A, I draw a tangent. This one here, once I draw it out, I'm going to just do this very, very quickly. What happens is that we get this, and we get this. You and I just said, hey, these are 90 degrees from tangent theorem A. If I then drew or constructed a line up the middle, what would happen is I would have an angle the same. Okay, our right angles would be the same. All right, and this length here is shared between the two triangles. And because this radius and this radius have to be equal, it's definition of radius, these two triangles are similar, which means that this length here and this length here have to be equal. So two tangents drawn from a common point will always be an equal length. So I'll just put some letters on here to help with the summary, that AB is equal to AC, and that's when two tangents are drawn through a common point. All right. So I'm going to end it there, and I'll do the examples just to clean this up, and just so I'm not rushed, and then you can move ahead and try some of the homework. So I'll see you in the next video.